Hello, my name is Kiara Howard, a graduating computer engineering student at FAMU FSU College of Engineering. This semester, I have the pleasure of completing research with the Asterix Consortium. My research focused on sensor fusion and tracking in autonomous vehicles. The main idea behind this is combining sensors in a way that generates a better understanding of the system. For example, how far you are from some object. In order to create the scenario, we use MATLAB's Driving Designer app. In order to import the map into the scenario, we use OpenStreetMap, where we're able to zoom in into the part of the map we want, which is exit 199 in Tallahassee, connected with North Monroe Street. Then click Export. Export again, and you can see that it saves a .osm file of the map that you just created. OpenStreetMap, you can use the import function and click OpenStreetMap to upload the .osm file, and you will see that it goes directly into MATLAB. So now we have Tallahassee's exit 199 in our scenario environment. And from there, you can go to the roads. So these are all of the different roads that are in the environment. And you can change the number of lanes, the width of the lanes, if they have solid, dashed, or again, solid markings. And you can also add actors into this scenario. So right now we have 15 vehicles in our scenario. And these actors can be a car, truck, bicycle, pedestrian, or even other barriers. And then we go on to add sensors in our scenario. So we have an INS sensor, which includes the accelerometer and the GPS that we use for our sensor fusion. We have a camera, radar, and LiDAR. And this is the sensor canvas that shows where all these sensors are located on the ECE vehicle. So as you can see, we have the 2 radar sensors in the front, along with a camera. And we have the 2 LiDAR sensors in the back, along with a camera. Here in the bird's eye plot, you can also see how the ECE vehicle is sensing what is around it with these sensors. So here we have our ECE vehicle, and it is currently sensing the truck behind it that's turning pretty wide for some reason, and the truck that is next to. In the egocentric view, you can see a 2D view of what's going on in the environment. So right now we're seeing the ECE vehicle in the blue and the truck that is next to it, which you can also see again here in our sensor canvas. You can also see the scenario in 3D. As you can see here, we have the ECE vehicle and the truck next to it moving along their waypoint path. And then on the right, we can see that the ECE vehicle is using the LiDAR, radar, and camera to detect objects near it. We can see here that the Ego vehicle is getting ready to turn off away from the truck while also still using those sensors to detect. After the scenario is put into place with all the actors, roads, barriers, and sensors, we're going to use the export function in the MATLAB function option to generate this scenario into code. After the function is generated into code, as seen here, we can see that it has all of these sensors, the road locations, the waypoints of all vehicles and lanes. And from this point, we can initialize all of the sensors so that we are able to use the data from them for sensor fusion and tracking. As autonomous vehicles, such as Tesla and other smaller applications like delivery robots, become growingly more popular, this research can be used to improve how these autonomous vehicles interpret the world around them. At this time, I would like to thank Dr. Shonda Bernardin, my mentor, Isaac Ogurundi, and the Department of Electrical and Computer Engineering for this opportunity. Thank you.